Okay. So, on Monday, we talked about scientific notation. And we did some problems where you put numbers into scientific notation. And with that, the main thing that came out is when we're talking about a number in scientific notation, if it has a negative superscript for the exponent, it means that it started out as a number less than 1. If it has a positive superscript or exponent, it means that it started out as a number greater than 1. So we talked about taking numbers and putting them into scientific notation. After that, we started our discussion of significant digits. Specifically, we were dealing with significant digits when it came to making a measurement. And when you make a measurement, you are supposed to record the digits you can read with absolute certainty, plus 1 uncertain digit. Now, we can recognize the digits we can read with certainty because there will be a mark for that digit. So 10, 10.1, 10.2. That means that if there's 10.3 and so on and so forth, that means we can read the tens place with absolute certainty because we can read the tens. We can read the ones place with absolute certainty. We can read the tenths place with absolute certainty. So therefore, our uncertain digit would fall in the hundredths place. So again, when you're making a measurement, you read everything you can read with absolute certainty. And then you read 1 additional digit, which is an estimated digit. So in other words, whatever digit you have to estimate on first, that's where you stop. Because you're only allowed 1 digit that you estimate. Now what we're going to do is we're going to talk about, so when we talked about significant digits on Monday, it was in regard to physically taking the measurement yourself. But what we're going to talk about today is taking and interpreting physical numbers that somebody else has read and determining how many significant digits they've recorded. So again, we're going to take and figure out how many significant digits somebody else has recorded. So the first thing I want to do is I want to introduce the concept of an exact number. An exact number has an unlimited or infinite number of significant digits. So let's discuss what counts as an exact number. An exact number is going to be a counting number. For example, there are 49 of you in my class. That's an exact number because I can't have a half a person. Therefore, that number has an infinite number of significant digits. Another example is your metric prefix conversion units. Both sides of this equality are exact numbers. And therefore would have an unlimited number of significant digits. So, for example, there are 1,000 milliliters in 1 liter. The 1,000 has an unlimited number of significant digits, an infinite number, as does the 1 for the 1 liter. Another example is going to be the term 1 mole when we start dealing with molar mass, which we won't get to until later in the semester. Also is 1 liter when we start dealing with molarity, which we won't get to until the very end of the semester. And then finally, mole to mole ratios. These are examples of values that are going to have an unlimited number of significant digits.
You say significant digits, like what exactly do you mean? Because I don't understand.
Important. So what digits are important and what digits are not important? When we start looking at which digits are important and which digits are not important, that becomes a value when we get into doing calculations. So you have to know which ones to keep, to how many to worry about and how many to not worry about that are in a number. That's what we mean by significant. It means they actually play a role in determining how many digits in a calculation should be kept. I think as we go, maybe the term will, I think as we get through Friday, because we'll get into the math on Friday, I think you'll start to see the importance of that term. But it's just it's a definition essentially. Significant means it's of value. It's something we take into account when we're doing mathematical calculations. Insignificant, which is the opposite, means that it's not important when we start looking at calculations. So I think once we actually use the term more, instead of just analyzing for it, it'll help. So if it doesn't by then, ask me again. Okay. So exact numbers have an unlimited number of significant digits, an unlimited number of digits that are important in thinking about calculations. Now let's talk about how we can determine if a digit is significant. The first rule is that all non-zero digits are significant. Rule 2. Is that all digits in the mantissa of a number in scientific notation are significant. So if I give you the number 3.10 times 10 to the negative 4, this is your mantissa. And so there are 3 significant digits. Number 3, zeros between 2 non-zero digits are significant. This is the goalpost effect. You got a non-zero, you got a non-zero. Everything in between is significant, whether it's 0 or not. So for example, if I have 1001, these are non-zero, or the ones are non-zero. So this number has 4 significant digits. Because of the goalpost effect. Zeros at the end of a number where that zero is after the decimal is significant. So for example, if I have 100.0, because this zero is at the end of the number and it is after the decimal, it is significant. The 1 is a non-zero, so it is significant. And then the 2 in the middle would be goal-posted by significant digits. So there are, again, 4 significant digits. Zeros at the end of a whole number where the decimal point is showing are significant. So 100 point this decimal point showing makes the 2 zeros before it significant. Now we get into insignificant. And there's actually only 2 rules for insignificant. Rule number 1 for insignificant is that zeros before the first non-zero digit are insignificant. An example is 0.000680. Don't even start counting your significant digits till you get to a non-zero digit. So I'm not even going to look at what's to the left. I'm going to start counting my significant digits at the 6. And in this case, there is 3 significant digits. The other rule is zeros at the end of a whole number where the decimal point is not showing are insignificant. So if I have 1010, that's a whole number because there's no decimal showing. There's no decimal places showing. So this is a whole number. So the zeros at the end of a whole number, if the decimal point is not showing, are insignificant. Or if I have the number 100, in this particular case, again, zeros at the end of a whole number. In other words, what I mean by at the end of a whole number is they occur after a non-zero digit. Zeros that occur after a non-zero digit at the end. Since there is no decimal point showing, are insignificant. Yes.
So for 100, would there just be one significant digit?
That is correct. There is only one significant digit in this number. In this top number, there are 3 significant digits. Other questions? Then let's look at examples. And I'm going to make them up so that you have plenty to work on yourself. Did everybody get the sign sheet? I have to report to you guys that has not completed class today, so. Want to make sure I got everybody. Yes.
I think this will have later. That was 2.0. Yes.
I will be very busy. So if I say lots of those,
Yeah, because they were. At least we're. I don't believe so. It's just a number. It's not. This is right here. So I think all three of those.
Oh, well.
I will, if I say it, to try to, so I've had a couple of people ask me about this one. If I want it to be I will say estimate or approximate if I'm not talking an exact number. But if I don't say estimate or approximate, I'm telling you it's an exact number. In other words, on these, you have to be very explicit in order for you to know whether it's exact or not.
Okay.
So I'll be very conscientious to say, oh, there's approximately 50 people in this class. Well, if I say there's approximately 50, then that's not exact. But if I say there's 50, then it's exact. So I will be very conscientious how I say those words to indicate whether it's an exact number or an approximate number.
I think it's yeah. But the zero at the end.
Yeah.
So there's.
It's infinite if if I had said approximately 20, then it would be that. But I didn't say approximately.
No.
How are we doing? Are we ready to see the answers? No, not yet? Okay. Okay, keep going. I will keep walking around.
Isn't exactly like it, I guess, I think this is good.
Okay.
This one. I guess it's.
Okay, so let's look at these answers. Apparently, I love the number 4. On this first one, these are significant, the 2 and the 3 are significant, and I'm gonna put SF to, instead of writing it out right now. Because of, they're non-zeros. But this one is not significant because there's no decimal point. For the whole number. So the answer to this first one is that there were 2 significant digits. This next one, again, this is the mantissa of a number in scientific notation, and all digits in the mantissa are significant. So there is 4 significant digits in the second one. Okay, the 1, 2, and the 3 are significant because they're non-zero. The 0 at the end is significant because it is at the end and after a decimal. But the 3 zeros preceding that first one are insignificant. Because you don't even start counting until you get to your first non-zero. So there were 4 significant digits in the third one. In the next one, the 2, the 1, and the 1 were all significant because they're non-zero digits. The 0 between the 2, 1, the 0 between the 21 and 1 is significant because it's goalposted. But the 0 at the end of the number is not significant because there is no decimal for the whole number. So again, there was 4. Like I said, apparently I love the number 4 today. This next one, the 2 and the 1 were significant because they're non-zero digits. But in this particular case, the zeros were also significant because the decimal point is showing. So again, there were 4. In the next one, again, this is a number in scientific notation, so all of the significant digits are found in the mantissa of the number. So there were 4. In the last one, or next to last one, the 1, 2, 3, and 6 are all significant because they're non-zero digits. This 0 is significant because it's at the end and after a decimal. So there were 5. And then the key here is I did not write anything preceding this. I just said there are 20 people. So this would be an exact number with an infinite number of significant digits. Questions? You have about, I don't know, A through I or A through L on your worksheet that you can do. And the answer key is posted. Don't worry about question number 2 on that worksheet. That's what we're going to deal with on Friday, which is getting into calculations with significant digits, which is the hardest part of significant digits. So I'm going to let you go and let you practice, and then we'll deal with calculations on Friday. A little bit early. It's up to you if you do any, I mean,